Hello, everybody. My name is Josh. I am a solutions architect at Pulumi, and with me is Adam. Adam, if you'd like to introduce yourself.
Yeah, hey y'all. My name is Adam Keller. I am a developer advocate with AWS, and specifically, I'm working with AWS Proton as well as just overall in the platform engineering and DevOps space over at AWS. So, really excited to be here and talk to y'all today.
All right. So, uh, if you have not yet done so, I definitely encourage everyone to sign up for a Pulumi account. If you sign up for a Pulumi account, you can use the Pulumi backend to manage your state file and your secrets. That is definitely the easiest way to get started. The Pulumi service is free to use for individual use forever, with essentially unlimited usage. So I definitely encourage you to, especially if you're learning Pulumi, use the Pulumi service backend. Once you are up and running with Pulumi, and if you think that your organization might be adopting it on a larger scale, I would encourage you to sign up for a 14-day free trial. That will give you 2 weeks of access to our enterprise-iest enterprise features, pretty much the full range of things that the Pulumi service offers. So you get 2 weeks of free access to all of that, including like SCIM, single sign-on, our most advanced policy as code features, all there. And there is no credit card required for that. So don't use your trial like right away if you're just like getting up and running with Pulumi. But like once you get comfortable with Pulumi and you're like, hey, I might want to show this to my organization, that's like a good time to sign up for a trial. Okay, so I'm going to hand off to Adam now, and he's going to tell you a little bit about Proton, platform engineering, and internal developer platforms. Take it away.
Thank you. So, first of all, again, thank you everybody for being here. Super excited to just talk about platform engineering, Proton, Pulumi, and how all of this kind of comes together. But usually when I talk about platform engineering, I like to start by just kind of talking about how we got to where we are today and how we've evolved. And, when we look at platform engineering, really it's all foundationally built on top of, the DevOps movement, DevOps culture with, the ultimate goal of bridging the gap between developers and operators, and infrastructure folks. We started where we had this kind of very siloed model where infrastructure people built infrastructure, they received a request, then they provisioned the infrastructure, provisioned the application to run on that infrastructure, and then it was ready to go. And the developer just said, here's my code, now you do the rest. Obviously, that was a slow process, very time consuming. And where we've gotten to is this kind of more modern era now where, folks are leveraging the cloud. They're taking advantage of managed services. We've kind of learned that if we don't have to manage a database, server, why do it? And let's offload that heavy lifting. Let the cloud take care of it. We're using more modern technologies, containers, serverless technologies. There's been this huge boom in leveraging serverless managed services and containers. And I mean, look, we see it with Kubernetes today. We see it with, serverless functionality like AWS Lambda. It's just exploded. And with that have come some really great infrastructure as code tools, Pulumi being one of them where, infrastructure as code started with defining as, YAML CloudFormation, but before that it was using Chef, Puppet, and we've kind of evolved into really programmatically defining your infrastructure as code. And, with that has a lot of power comes with that, right? You can have a lot of conditional logic and really make smart decisions when you build your infrastructure using infrastructure as code. And of course, CI/CD pipelines have become all the rage, and that's even evolved into using Git as the source of truth. So we've seen a lot of, pipelines kind of taking over Git with GitOps, and finding modern approaches to deploying code, deploying infrastructure as well. And of course, the last thing to mention here is microservices, right? We've gone from this monolithic model of developing software to a more microservice model. And one thing I want to say is there's no right or wrong approach to how you build software and how you build infrastructure. Ultimately, what it comes down to is what's the best model to support the culture of the organization and to support your teams. But with that, we found that microservices obviously give you more agility, so you can move faster, deploy faster. Your blast radius is lessened because if you break your microservice, you're not breaking the entire application and throwing up a 500 error on your website for the entire page. Maybe it's just one particular function of your application. But with that, while we gained a lot of advantages, ultimately what we've realized is that we've kind of sold it as maybe some people have sold it as being simpler. Maybe some have said it's a simpler approach, but I think what we've realized is it's not. To build microservices, to build out your infrastructure as code, there are still a lot of resources that need to be created. And we still have to think about how do we deploy these resources. And then once those resources are deployed and our application's deployed, how are we monitoring it? How are we keeping track of the health of our application, the health of our infrastructure to ensure that, we're not just going down and no one's aware of it. So, what we've seen is with the DevOps movement that we've made some pretty great progress. Developers get these CI/CD pipelines, this really awesome automation, but it's still, the developers are still focused on, when we're bringing the two teams together, there's still a lot of focus on infrastructure, and developers still have to kind of think about a lot of the, what's on the infrastructure side, and there's a lot of work. And ultimately what we're hearing is developers don't always want to be experts and, be the 10X developer, right? They want to do what they do really well, which is build application code, and deploy that code. So they're looking for standardization, but with all of this, we want to enable developers to build at their pace in a self-service model, but ultimately have the guardrails in place to do that. And with that, we've seen, in practice, we see these giant abstractions that are being built by platform teams, mega pipelines, this one CI/CD pipeline that kind of deploys everything. I call it like the Uber CI/CD pipeline that deploys all your infrastructure across many accounts. And it becomes really hard when someone wants to come in and maintain that or contribute or build on top of that. So ultimately what we've seen is with all the good that's come out of this, in reality, there's still a lot of complexity to manage, and we're still looking for ways to simplify that. And this is where platform engineering has come in. And again, I will say platform engineering, in my opinion, is just an extension of DevOps. I think titles are great, but at the end of the day, we all have the same goal in mind. And that goal is to just make developers' lives easier so they can serve their end user, which is, the customer, so they can fix bugs faster, provide features faster. And the operations teams, the infrastructures teams can build resources and define them in a way that enables developers to move faster. And that ultimately the developers are their customers. So to put it simply, platform engineering is just looking to bridge that gap with self-service interfaces and ways for the developers to get what they need with all the guardrails and compliance built in. So with that, we've seen the boom in platform engineering in two kind of emerging patterns. One of those is GitOps, where, GitOps, there's a whole thing on a definition on it according to the CNCF, but ultimately the idea behind GitOps is you use Git as the source of truth, and anytime a manifest is updated in GitOps or any change is made, there's a controller out there that's going to apply that change, and if anything changes manually outside of code, that controller is going to reconcile and make sure that desired state is always being met. And then on the other side, we have self-service developer platforms, otherwise known as internal developer platforms. Sometimes you'll hear in internal developer portals, but ultimately the goal of a self-service developer platform is to set your standards and build common blueprints that represent your organization and your best practices of how you operate. So an example may be, defining Kubernetes clusters and then defining a standard way to deploy your applications onto those Kubernetes clusters that meet compliance, that follow the guardrails, and ensure that what a developer is deploying is safe according to your standards. So AWS Proton aims to solve the problem of platform engineering and having to manage the platform on your own. So as I mentioned earlier, platform engineering, the goal is to bridge the gap between developers and infrastructure operators, and Proton really believes in that as its mission. So I like to refer to Proton as infrastructure as code orchestration, where ultimately the platform team is defining the templates that developers can deploy from. Oftentimes we call this golden path, where we're saying, here are the patterns that you can use to deploy. And, oftentimes these patterns are, like I mentioned earlier, containerized services, serverless functions that are, behind an API gateway. And these patterns deploy to all your shared environments based on where, you want them to deploy. So a couple features about Proton, and I realize I'm talking a lot. I could honestly talk all day, but I want to get to the demo because I think that's where the most fun is. But Proton provides some pretty powerful functionality that we found our customers have found to be really exciting and they've had great success with. One is the self-service interface. So as a platform engineer, you're able to define your templates centrally, store them in Git, and use Git as that source of truth. And Proton will actually automatically present templates and publish those templates based on what you've stored in Git and when you set up that sync process. But it has that really nice self-service interface for developers to go in. They have a nice catalog of different blueprints or patterns that they can choose from. They pass in their inputs to configure the infrastructure as code, and then Proton actually deploys that infrastructure as code on their behalf. So from the developer's perspective, they get that nice self-service interface, whether that's via the console or APIs, and Proton manages the deployment of those resources, as well as the insight and visibility into all the resources that have been deployed across accounts using AWS Proton. And the last feature I'll talk about with Proton is the versioning system. So one common problem we see out there in the wild is, as customers grow and their footprint gets really large, having insight into knowing what you've deployed across all your different environments becomes very challenging. And where that challenge becomes even more of a potential problem is when you need to apply a fix. And, let's just say, there's an AMI that you're referencing, an Amazon machine image, right? And that machine image is referencing a particular package on the operating system that now has a pretty critical vulnerability. Well, in order to find out what version of infrastructure as code is running across all your environments, you have to do some creative digging to figure out what's running where. Well, with Proton, that's all central in the Proton dashboard. I can very quickly see what version of my infrastructure as code templates are running where, and then we can take the appropriate action, do a one-click upgrade, and then we can get to that latest version. So that's it for Proton. I'm going to pass it off to Josh, and we'll go from there.
Okay, and folks, I'm going to go a little faster than I usually go because I want to make sure that I'm able to get to the code because the code is more extensive than it usually is for one of these hour-long workshops. Okay, so what is Pulumi? Pulumi is an infrastructure as code tool. The essential elements of it are that it allows you to use real programming languages. We'll go over the full list in a moment on one of the future slides. And it works with a multitude of clouds. So it works with AWS, the other public clouds that we won't mention by name, but you probably know them. And also a long tail of like SaaS solutions. So like Datadog, New Relic, GitHub, GitLab, so on and so forth. Auth0, I think. There's like a huge range of providers that Pulumi can work with. So like essentially that is the crux of like Pulumi is real programming languages, and then it works with a multitude of clouds. Pulumi is open source. All the stuff that we're doing today is either open source or using the free version of our SaaS backend. Do know that the only cost that would be incurred by running this demo would be the cost of the AWS resources, and that should also be likewise pretty minimal. A little bit about Pulumi's program model. So at the overarching kind of structure, the big container is a project. You don't generally deal with projects directly. Within a project, you have a program. That's your code. For us, that's going to be a TypeScript file. Within your program, you're defining resources. An example of a resource is like a VPC or an S3 bucket. Resources have inputs and outputs. And so you will very frequently see this pattern where the output of one resource becomes the input of the next resource. For example, you might define an AWS S3 bucket, and the bucket name output would become the input of a policy that you might apply to the bucket. And so you'll see that pattern repeated in our code. Likewise, so behind the scenes within those inputs and outputs, that's where Pulumi is keeping track of what needs to be changed or created or destroyed and in what order. So that's kind of where the magic happens, and that's what allows you to make your Pulumi program declarative. You don't have to say, I want to update this attribute of this bucket and then change like this part of the policy. Pulumi will keep track of those dependencies for you behind the scene. In addition to our program where we define our resources, we have stacks. Stacks are essentially instances of the program. A very, very common use for stacks is to make different environments. So like your QA, dev, and prod. That is actually not as applicable when you're using Proton, as we'll see later, but it's just important to know, how you would do this in a sort of vanilla Pulumi situation. A quick overview of Pulumi's model. So we have our Pulumi program. That is where we are writing our code. Pulumi programs can be written in a wide range of languages, including Python, TypeScript, JavaScript. That's what we'll be using today. But we also support Go, C#, F#. We have Java support, which is in preview. And we also have YAML. YAML is kind of like there for organizations that might not be ready to take like a full step to using full programming languages to define their infrastructure as code. And it's kind of there so that like folks have a little bit easier onboarding if they're not yet comfortable with writing code, real programming languages to define infrastructure. Your Pulumi program is executed by the Pulumi engine. That is like the Pulumi CLI. It is going to interact with the Pulumi service to read your state file to find out what state your infrastructure is in. And then it is going to interact with one-to-many Pulumi providers to actually change your resources. So today we'll be using the AWS provider. That is what is making the actual API call to the API, AWS API. And but there are other providers out there. Like we have a Kubernetes provider that is like very popular. And so like, it is very much idiomatic to use multiple providers in a single Pulumi program. So you might want to spin up an EKS cluster and then deploy some Kubernetes manifests onto that cluster. And that's a very common use of Pulumi. Okay, so now we're up to demo time. I'm going to check the Q&A tab real quick. Okay, that is a long question, and I'm going to have to get to that a little bit later because I want to make sure that I get through the code. I am going to share my screen. I'm going to rearrange some windows. Please be patient. All right, we're going to share this screen. We're going to make sure we share the entire screen and the correct screen. Okay, so folks should now see Visual Studio Code. And now we get to play my favorite part, my favorite game in any workshop. We're going to play a game called Is It Large Enough for You to Read? How does that look to you, Adam? Does that look reasonable?
Yeah, that looks pretty good.
Okay, and I'm going to,
if anyone complains, I will interrupt you and let you know.
Yes, please do. Okay, so taking a tour of the code. There are two important concepts to understand in Proton. There are environments and there are services. Your environment is like your shared infrastructure, and that is typically going to be defined by your platform team and deployed by your platform team. So I'm going, and then on top of into those environments, you will be deploying services. And your services, the templates are still going to be defined by your platform team, but the actual deployment is typically going to be happening by your application development team. So, so as a service team member, I'm going to like come into the Proton UI and fill out a form, and then I'm going to click a button, and then it will deploy. I will also select the environment into which I am deploying my service, and then my service will be deployed. You'll see that in detail very shortly. So in this Proton templates directory, we have an environment template and a service template. In the environment template, it's important to note that when you bundle Proton templates, they do have to have a prescribed structure to them. And that is detailed, of course, in the Proton docs. So within the infrastructure folder here, this is like where you're going to see like the stuff that looks very familiar if you've worked with Pulumi before, plus a couple extra things that I will go into very shortly. So in our Pulumi program, this is a pretty straightforward Pulumi program. I'm going to highlight a few lines. So we create a VPC. This is the AWS VPC. So this creates like a VPC and subnets and NAT gateways and all that goodness. So you have a fully functioning VPC like right out of the box with just a couple of lines of code. We also create an ECS cluster. We're going to deploy a Fargate service onto that in the service portion. And we have a security group for our load balancer. This is not, by the way, 100% production ready. This could certainly be tweaked to be a little bit more both flexible and like a little bit more secure. So don't use this right out of the box for like production, but it should give you a really, really good starting point. And then we also have an ALB, and we are deploying our ALB into the public subnet of our VPC. So here's an example. I'm going to highlight over this. That is any. I know why. Normally in a Pulumi program, you would get the hard typing, but because of the way that we have this set up, you'll notice that there's no node modules here. That's because when we deploy our Proton template, we do not include node modules. They will get grabbed when Proton runs the template. You'll see all of this later. The important thing to take away from this is this is our shared infrastructure. So we have a VPC, we have an ECS cluster, and we have a load balancer. And all of the services that we deploy into this environment are going to use this shared infrastructure. At the bottom of our file, we have some outputs. These are stack outputs in Pulumi. In TypeScript, you do that just by adding the export keyword. So we're exporting the VPC ID, the private subnet IDs, the cluster ARN, the load balancer ARN, and load balancer DNS name. And all of these things are there because they are going to be consumed by our service template. Notice, by the way, that we do not export the public subnet IDs because we do not want people deploying services directly into public subnets. That's what the load balancer is partially there for. Okay, so that is, are we so far so good? I can't really see the chat because I only have 2 monitors and one of them has my notes. But Adam, you can give me a thumbs up.
Yeah, I just want to add. Yeah, it seems like everyone's good. There was one person just mentioned maybe some confusion around services, and I just think with Proton, like when you think about services, think the blueprint that defines how your application runs. So if that's a container, if that's a serverless function, it's whatever the infrastructure that is required for your application to run. And then the environment is just those shared resources, as Josh said, which, by the way, Josh, I wanted to commend you. You explained it like maybe you should be the Proton developer advocate because that was really good. But the environment is where your shared resources live. And essentially, when you deploy a service through Proton, Proton bridges environments and services together through inputs and outputs. So you make your configurable inputs in the schema file, and then Proton is able to then dynamically configure resources based on those values. So anyways, Josh, so far so good.
Cool. Okay. So how does Proton actually run Pulumi commands? It does it by using code build, which is, for those that don't know, code build is AWS's managed continuous integration service. To boil it down to a very, very simple concept, it is basically they give you a container and it runs bash commands, whatever you supply it. And you define those bash commands in this file, manifest.yaml. So there are two scripts that you're basically going to be supplying here. One is to provision the infrastructure that is going to run a few Pulumi commands and then run Pulumi up. And then there's also a deprovision section that's going to do whatever it needs to do to set up, and then it's going to run Pulumi destroy. So it's pretty straightforward. Let's take a quick tour through our provision script. Okay, so we have some debugging stuff. You can ignore that safely. Okay, so we're going to download Pulumi. We're going to run npm install. That's going to give us our node modules back. And then we're going to run some Pulumi commands to essentially configure the environment. So we have a stack name, right? And so what you can't see here, but I have a sample over here, and I'll go into it in just a moment. Proton takes the inputs that you give through the console, and it puts them in a known JSON file called proton-inputs.json. And then, so what we're doing here is we're taking proton-inputs.json, and we're using the JQ command line tool to get those values and then pass them to our Pulumi stack. For example, we're grabbing the stack name. You'll see more configuration actually when we go from when we go over the service template, because that's going to be using all of the outputs from the environment, which are passed along to the service. If you want to see what that looks like for an environment, here is a sample file. So the environment name gets passed through. So we use that environment name. That's going to become the name of our VPC. And then we also, this is actually a little bit outdated, but essentially the one to keep an eye on here is the name. So we'll use this name, and then over in our Pulumi program, we pull that in using the Pulumi config functionality. We require the name. We also require a CIDR block. And then we use this name down here when we actually name the VPC resource. And so this name will filter down into everything that you see in the console. So if you're looking at the VPC, if you call this thing, my environment, the VPC will end up being called my environment-VPC. The subnets will have names that are also based off of that. So you'll see which ones are the public subnets and the private subnets and stuff like that. And then we also pass through the CIDR block as a configuration parameter, just as a sort of demonstration. It doesn't actually have any effect on this particular infrastructure we build, but if you can think of a scenario where you might have a hub and spoke network with centralized egress, those VPC CIDR blocks become very, very important because you need them to not collide, and so you need them to be parameterizable.
Josh, can I say something?
So that is the environment template. Go right ahead.
And I think, so Pulumi, super powerful because you can programmatically define your infrastructure as code. You're using TypeScript here. Now imagine as you get more advanced in your templates, maybe you want to make one of the optional inputs load balancer. Maybe you want to have a central load balancer in your VPC. So with Pulumi, I could have a conditional statement in my code that says if load balancer was enabled, so if that Boolean value was set to true when someone created the environment, create a load balancer, create this shared load balancer. But if not, then that load balancer never gets created. So you can really get, there's a lot of power that you have when you mix Pulumi with Proton here, because you can have this really nice self-service interface with all these options, and the end user is just selecting what they want, and programmatically you're able to make decisions at deploy time, at render time. So that was all I want to say. Thanks, Josh.
Awesome. So then the next question is well, how do we let the console user know what inputs are available? And so that comes from this file under schema.yaml. It is a YAML file that essentially lets you define what the inputs, the possible inputs are. This is a pretty minimal example. So right here, we just have the VPC CIDR block. Environments always have a name anyway, so you don't actually have to define that in the schema block. But there's like a lot you can do with this file. You can say which ones are required. You can add validation to these inputs. So like, if I had more time, I could add a validator here that would like ensure that this is actually a valid cycle block. And so, but let's get to like the actual action here. And where do we go here? Where'd you go? There you are, Proton console. Okay, so, and now can folks see this? I'm making it nice and big. Hopefully that is okay. And give me a thumbs up if that looks good to you.
A little bigger.
A little bigger. All right, all right, cool. So here's the Proton dashboard. And what we're going to do now is we are going to create an environment. Okay, create an environment. So here is our environment template. It's called Fargate-env. I may at some point after this workshop go and clean some of these up so the names are a little bit more consistent. But we're going to select that environment. We're going to click configure. Okay. So under provisioning, we're going to leave this alone because we are using code build provisioning, so that's basically none of the above. We're going to go to which deployment account. We're going to deploy to this account, which is fine. We're going to give this environment a name, my env. We can give it an optional description, but we're not going to do that here. And then we need to select which role is going to be used to deploy it. I will show you how I created this code build role later if there's time. But I'm going to select this role that I created using Pulumi, actually. Okay, and then we can add some tags if we need to, but we don't need to do that. So let's click next. Okay, now we are able to optionally enter the cyber block. Let's go 10.3.0.0.16. Total classic cyber block. And then we're going to hit next. Okay, so then we're going to get a chance to review the inputs that we did. They all look good because this is a simple example. And then we're going to click create. Okay, so now we can see that our deployment status here is in progress. What I'm going to do is I'm actually going to reload the page. And now that we reload the page, oh, look at this. We have code build provisioning. And so what we can do is we can click this link to the code build job, which will take us into the code build console. And we can tail the logs and we can watch it do its thing. And we're not going to stick around here for the entire creation process. I'm actually going to jump back to the code so that we can maximize our time together. But very shortly, I'm going to jump back to the code now. We'll check back in here. But what you'll see that these commands that we defined in our manifest.yaml, they're going to start executing. And then we're going to deploy our infrastructure using Pulumi. Let's see, do we have any? We don't have any output yet, but that's okay because we have plenty more to show. Okay, so that is the environment template. Now let's take a look at the service template. Okay, so our service template, likewise, this should look pretty familiar. Let's go into the Pulumi program. This is the index.ts file. And what are we doing here? Okay, so we are requiring, now remember that we had all of these outputs at the end of the environment. Well, we're now making them required configuration parameters for the service because this is how the service knows where to deploy its infrastructure. And so what is that infrastructure? And let me also preface this by saying the partitioning of the infrastructure between environment and service is not necessarily optimal. That's another thing that I'd like to work on if I have time. So you may see a few minor changes to this after this workshop is concluded. So you might want to keep an eye on the workshops repo that is linked in the handouts. That's where all the code is. So we create a target group for our service and an HTTP listener on the load balancer. And so when we create this target group, right, we have this VPC ID. And then where is this VPC ID ultimately coming from? It is coming from the environment. And how do we get our environment? Well, when we create our service, we select which environment it's going into. And when we do that, Proton will create a Proton inputs.json file that includes all of the outputs of the environment. And so that's right here. That is this file. So you can see that this is a lot longer than the JSON file that we had for our environment. Our environment's very short, but our service contains not only our inputs to the service, but also all of the outputs from the environment. And so like here, for example, is like, you know, the VPC ID that we're going to use to deploy our listener. So hopefully everybody's following so far. So point being, you get the outputs of the environment are passed as inputs to the service.
Can I add one thing, Josh, really quick?
Go right ahead.
Could you go back to that input really fast?
Yeah.
In addition, and again, you're explaining Proton so beautifully. One other thing that's really cool about the service templates is you can also bundle a pipeline definition in your service template. So if you decided that you wanted to have a pipeline, what Proton would give you here is the pipeline inputs as well. So if you want to make these templates generic, so one thing is maybe you want to let you have a polyglot environment where one team writes in Go, the other team develops in Python, but they all need to run unit tests. So you could just say, what's your unit test script location? And then in your pipeline, you're just going to run that line based on what the user passed in. And this is where you'll get all that information. So super powerful. You can really build extensive, like full-fledged services here with pipelines end to end, and Proton will, fill in those blanks in this file.
All right, that is excellent. Oh, and so we can see, by the way, that our VPC is being created. We're now down to the load balancer. So our environment is progressing along very nicely. Back to our service. So we're going to create a target group, a listener, an IAM role to run our Fargate task. We have a task definition, and it is running. We're just going to run Nginx essentially. So we're going to create a Fargate task. If you don't know what Fargate is AWS's managed serverless container orchestrator. It basically means that you can run containers without having to worry about the hosts on which they're actually running. You just point it kind of at a VPC and say, scale out within this VPC, and it does its thing. It's an excellent option if you are running an application on containers and are just kind of getting started and don't want to have to necessarily deal with the complexity of running like a Kubernetes cluster. We have a security group. The security group is basically to allow traffic properly from our Fargate cluster. We need to be able to download the actual Nginx container. That's why we have to allow port 443. And then port 80 is where the actual Nginx traffic will flow. Again, this is not a production ready setup. You would normally have like HTTPS and have that terminate the load balancer. But for simplicity, we're just going to run straight port 80 through to Nginx. Finally, we define the service. The service is going to be deployed into our private subnets. That's where you want it. You don't necessarily want your container to be publicly addressable. Typically, you do not. And then the last thing we're going to do is we're going to export our service URL. Again, in a more, one of the things I do want to eventually do to improve this demo code is to allow it to support multiple services in a single environment. Right now, it only supports one. So this URL would, if we had multiple services, there would be like an extra URL segment tacked on to the end, and we would use layer 7 based routing to be like, okay, whatever.amazon.aws.com/service1 will route to the first service /service2 would route to the second one. So that's a future enhancement that hopefully we'll be able to get out at some point. Looking at the schema, our schema.yaml. So this is what defines the console inputs for a service. This is essentially a dummy. This is a dummy input basically, but we're going to allow you to define the service port. It doesn't actually work at present, but that is definitely something that you might, in a more production scenario, like one clear example of like a parameter to the service would be the name of the container, right? So you're going to have like my.org/ login service or my.org/ orders service or whatever. That's like how you would use it in a more production scenario. So like each team would fill out what the name of the container is that contains their application code. Okay, so let's see how okay, good. So our environment is now deployed, and we can close the code build tab. Back in Proton Town, so we see our environment is called myenv, and if we hop on over to the VPC console, lo and behold, if we go to our VPCs, we see that we have my environment VPC right here. So that is what we just deployed. There is the CIDR block that we defined, and we can see that our inputs to our environment have been passed along to the actual generated infrastructure. Great. Okay, so let's go back to Proton.
And a really cool thing to highlight there, Josh, is so all you did as the platform engineer, and when I say all you did, I'm not trying to, lessen all the hard work, but like you just defined your templates using infrastructure as code, right? You're comfortable. That's your territory. You feel good there. What you didn't have to do was build an infrastructure pipeline. You didn't have to think about cross-account roles and like all the complexities that come with automating deploying of these resources. You just, here's my template bundle, here's my infrastructure as code, published it, and then went through the self-service interface, and Proton handles the rest. So it's just kind of neat that you don't have to think about all of those complex things anymore. You're just really focusing on the value to you, which is defining the infrastructure in a way that's reproducible and deployable.
Excellent. So now that we're ready to create a service, we're going to choose our service template. It's the same single template that we just went over in Visual Studio Code. We're going to click configure. We're going to give it a name. Call it my service. Cool. And then we can define some tags if you want to. That's optional. We're going to skip that for now. And we're also going to define a service instance name. So you can actually deploy multiple instances of the same service into multiple environments at once. We'll call this my service instance. And we need to select the environment. It's worth noting that behind the scenes, Proton will let you do some pretty sophisticated things so that you can ensure that a service is only deployed into a compatible environment. And not only a compatible environment, but a compatible major version of that environment. You can do, and we're not going to show that here today, but you do, when you create environment templates, there is semantic versioning that you attach to that. So you can create a new version of an environment, and it might not even be available to anybody yet. You actually have to explicitly publish it. So it's like, this is like such a huge leap forward for these types of managed services. This is like really, Proton is like really one of the nicest products I've seen in this area. So we're going to select the environment that we just deployed into, my environment. We're going to enter our service port, which doesn't actually do anything. Don't tell anybody. We're going to click next. Okay, again, we get a chance to review all the choices we made. We feel pretty good about them. And we're going to click create. Okay, and so now we see our service status has create in progress. I'm going to reload the page, and we're going to go to this service instance. We're going to click here. And lo and behold, we have our code build provisioning link. And if we click this, it will open the code build console in a new tab. And again, we can tail the logs and keep an eye on what's going on. So it is now running like npm install. Pulumi has already been installed, and it's eventually going to run Pulumi up. So at this point, I think I want to, let's actually, you know what? We only have about 10 minutes left. I am, by the way, more than happy to stick around. I could talk about this for another hour if folks wanted to, but I don't know that there is necessarily that much demand. That said, maybe this would be a good time to check in on Q&A. How are folks doing over there? Is everybody following? Does this all make sense?
And Josh, there was one question. Yeah, the most recent one I think you may be able to help with is, how does Proton compare to using Pulumi's automated deployments? Could you use them in conjunction? Are they more competing?
So I think that if you were using Proton, you would probably not be using Pulumi deployments. Now that said, there's still a lot of value in those scenarios that comes from using the Pulumi service, which I can bring up right now, actually. So this is the Pulumi service. One example that comes to mind, right, is if you are on Pulumi's business critical level of service, we give you the ability to define. So Pulumi has a policies code feature called policy packs, and you can, when you're on business critical, you can define a policy pack that needs to apply to every stack in your organization. So if you need HIPAA compliance and there's certain AWS services that you can't allow anyone to use, you can write one rule in code to ensure that those services are not used, and they will automatically be applied to all stacks across your organization. So no, you would not necessarily be using Pulumi deployments if you're using Proton, but there's still, you would still probably want to use the Pulumi service. By the way, in the Pulumi service, you do get a history of, this is our service that's being spun up. I guess it just finished. Within the Pulumi service, by the way, you get the output, the same output that you would see from the Pulumi CLI, as well as like the change history to any stacks and any stacks that have been spun up or down as well. So you get that history in there that's like so important when you're like trying to figure out like who changed what and when and possibly why. That's always good to know when you're working with production workloads. Also in the Pulumi service, again, you have like, we have a dashboard that shows you like your resource count over time, stuff like that. So I think that ultimately like Proton and the Pulumi service work really well together. But you would not be using the specific feature of Pulumi deployments in all likelihood if you are using Proton. Let's check back, by the way, on code build. Okay, so we are all done. Our service has been deployed. And if we go back to the Proton console, we can reload the page. And if we scroll down, oh, I think it's actually with this. Oh, no, here it is. So if we look here, details, outputs, we have our service URL. Let's copy that. Let's paste it into the browser. And lo and behold, we have ourselves a new, fresh, fully functional instance of Nginx. So it works, which is always good to know. So we only have about 8 minutes left. I want to make sure I take this time to cover any questions because this is a particularly dense presentation. I know I went over a lot of stuff. What else can I help folks with? Let's see if we have some questions here. Can you deploy services to environments that you already set up outside of Proton? For example, existing ECS clusters. Yes, you can. There's a lot of different ways you could accomplish that, but essentially you just need to get the cluster ID and any other supporting IDs and infrastructures to Pulumi. And there are a lot of ways to do that in Pulumi. You could hard code it. Pulumi has what's called a get method on every resource type. So you can query, for example, a VPC by a VPC ID or other, there are functions within the AWS provider to grab a VPC by different identifying characteristics. You might be looking for something with a specific tag. Again, so there's lots of ways to reuse that existing infrastructure outside of that was created outside of Pulumi. You can also, by the way, import resources into Pulumi and so you would be able to potentially create a Proton environment or another Pulumi program and import your existing infrastructure. If you go to our blog, I wrote a blog post about that very subject pretty recently. Let me see if I can grab it, and I'll try and throw it in the handouts or for you.
And
yes,
so on top of that, so you can also with Proton, if you manage a stack outside, but like oftentimes what we see with customers is they kind of want to move to Proton, but they want to do more of like that strangler method type approach where you slowly isolate your stuff created outside. Proton has a feature called customer managed environments where basically you could define an environment and your environment is literally just the outputs. So VPC ID, ECS cluster, ARN, whatever you'd want to share. And then when you create a service definition in Proton and you deploy it to that environment, and I'm air quoting here, it's going to grab those outputs. And that's how Proton knows of those values. So if you wanted to do that like natively in Proton, that's how you could do it creatively there.
So Graham asks a great question. Can you provision the application on top of the infrastructure with Proton, or is it just for the infrastructure? So Graham, this is actually a fairly nuanced answer. If you are deploying a containerized service, the application is the infrastructure. However, if you have a scenario, for example, where you're running software on VMs, you could just as easily define in your infrastructure as code, you could define a code deployment and do it that way. Or, with these, because you're using code build as your provisioner, if you can deploy it by executing bash or PowerShell commands, I believe the Windows containers are also supported. Check me on that, Adam, make sure that's correct. But essentially, if you can deploy it using a script, yeah, good. So that is supported. If you can deploy it using a script, then you can use Proton to do this. You don't even need to be using Pulumi at all necessarily. You can pass parameters, if you're using Capistrano, I think. You could just pass parameters like Capistrano if you're deploying a Ruby application like onto virtual machines. We have a lot more questions. How does Proton auto tagging work if Pulumi is provisioning the environment? Does it work if using CloudFormation provisioning? So Proton is going to tag in the console, right? Proton's going to generate tags for, let's say, the environment, regardless, I believe, right? Yes. So it's going to have these sort of AWS generated Proton tags. If you want to tag the actual resources the environment is creating, then in that case, you would just pass them through to your Pulumi program and then apply them however you need to using Pulumi. If you are using the AWS, if you're using the AWSX VPC component, the name of the resource, which we call myenv-vpc or whatever, those names are going to automatically filter down because that's how we design the component. So you will see those name tags in the console. Are there any other questions? Let's see. I think we covered too much. Maybe everybody's mind is so full there's no room for questions. Go ahead.
There's what can the templates be managed directly through Proton? And I'd probably like to get some more, elaborate a little more on that. But I mean, Proton essentially, you define your templates, whether that's in Git or in S3, and then you tell Proton, here's the location of the template, and then Proton knows what to deploy and what to render at deploy time.
Yeah, the example code, by the way, uses S3, but in a production scenario, you should probably use Git sync instead. The reason that we use S3 for this demo code is that it allows us to keep all the code in one repository so that things like can't possibly get out of sync. And I didn't really get a chance to dive too much into this, but it's worth mentioning that I actually set up Proton and the templates themselves using Pulumi that I ran on my local machine. So it's like a little bit of an Inception type thing, if you're familiar with that movie. When we set up the Proton resources, they're actually pretty minimal. We have a role that code build can assume that's going to allow it to create AWS resources. So we give code build full admin, that's like pretty standard practice. So if that raises some hairs in the back of your neck, that is actually pretty normal. For tools like Pulumi, that you do want to give them a role with full administrative access, because if you give them anything short of that, they're not going to be able to create IAM roles, which are like pretty critical for most real world usages. So like, for example, most of the time, you're not going to be able to run like a serverless application unless you are allowed to create IAM roles, which in turn requires full administrator. So that is normal. In addition, so we have that role. We're going to apply that role to code build. We're also passing our Pulumi access token. So that's what allows us to interact with the Pulumi service. We are putting that in secrets manager. And then we give it, so we're essentially creating a secret and a secret version. That's so when code build does its thing, we are actually passing that through to code build as an environment variable. And you can see all of the details of how that works in manifest.yaml. And then we're also creating a bucket in which to place our templates. So that's essentially how the Proton infrastructure works. If you want to look at the details, you can also dive into the environment template folder and the service template folder. That is what actually uploads the gzipped template up here. So we have a make file that I know I'm like really, really tacking on quite a bit to the end of this workshop, but hopefully the folks are following along. We have a make file. The make file will take the code for our template and tar it and gzip it. And then if you run this Pulumi stack, it will upload the template into S3 and create and publish a new version of the template. You can also do all of this through the UI. The reason that I decided to automate it is that in authoring this workshop, I was running through this over and over and over again. And so it became very much worth my while to actually try and automate it as much as possible because I was doing it so many times. If you're doing this in practice, it may be totally fine to like set these things up just through the Proton console. Adam, if you, by the way, have to go, no worries. I can stick around for a little while and try to answer the remaining questions. Up to you. So we have a question. Can I use IAM to allow access deployment to groups of templates to a group of users? I would certainly imagine so, but Adam, if you want to fill in some details there.
Yeah, so this is something we're looking at with Proton. So today you do have some control over who can deploy what in the Proton console and APIs. However, we are looking at having more advanced identity and access management privileges there. So if that's something that you're interested in and you have some really good use cases, I'm just going to post my email in here. Please feel free to reach out to me because that's something we're actively looking at right now.
Awesome. So Camilla asks, what are some of the potential pitfalls to be aware of when using this combination, Pulumi plus Proton? All right, so you don't want to do platform engineering in your company until like you're ready to do it. Some of the skills that you're going to need, some of the skills are going to be necessary. Okay, you're going to have to understand how to separate environments versus services and which resources go into which place, because if that gets messed up, and you start having a whole bunch of developers, deploying their services, and then you're like, uh-oh, we put something in the wrong place. That's going to be difficult to fix. Not impossible, just difficult. It's very expensive in terms of time, not necessarily in terms of money. You definitely, your platform engineering team needs to understand how to keep stable versions of environments and services. You do not want to be unnecessarily creating new major versions of either environments or services. And so and these are skills that can be learned. They're not inherent. No one's born understanding semantic versioning or how to partition infrastructure between environments and services. But start small, I would say. Start small. Try to put really obvious shared infrastructure like VPCs. You probably don't want a service application team having to define their own CIDR block or aspects of their VPC. That's a really great starting point. That's really easy to, that's very clearly an environment in my mind. Typically, you're going to want to have some sort of shared, if you're using ECS or EKS clusters, those are also very good candidates to go into environments. Again, I would say definitely don't be in a rush to roll this out to your entire organization. Start small, make sure you go through a few major revisions and that your templates are relatively stable before you start to roll them out en masse. I think those are those are the biggest pitfalls that I can think of.
Yeah.
Adam, anything you want to add to that?
Yeah, I think if I can just add a couple things, I agree with everything you're saying. One, it's very common, and this is in platform engineering in general. When we build these platforms to enable developers to self-serve, one of the biggest failure points is we think we can solve all the problems in this central self-service platform. And the reality is we can probably get to about 80%, but at some point you're not going to be able to solve every problem at your organization. So recognize and start, as Josh said, you start small, recognize the problems that you can solve, build your templates, make sure you think programmatically when you're defining these templates and have, that conditional logic to, use that schema to have some conditions to deploy things or not deploy things based on inputs. But also, really quick segue here, Proton does have a feature called components, where when you get to that point where you just simply can't solve every problem, and there's that like the 80-20 rule, 80% you've solved with the platform, but there's 20% that you just can't possibly do everything. This is where components help. Developers can come in and actually bring their own infrastructure as code and deploy it on top of their services. So I'm not going to dive into that now, but I think as we look forward and as we look at how we're building platforms in the future, this is going to be critical because you got to be able to think of the developers that need to self-serve, but also self-enable. And that's where, features like components will help. And
one more thing, okay.
So sorry, there was one more question that I was going to touch on too, and I see my camera's off, but hopefully my audio is okay. Proton is not opinionated about where you deploy to. So as Josh was showing, Proton launches a code build job and then deploys your infrastructure as code based on what you have defined there. So if that means that you want to deploy somewhere else, you absolutely can. Proton is not forcing you to deploy to one particular cloud. It just runs in AWS, runs that code build job, runs your infrastructure as code. So if you want to deploy something into your, data center, you can do that with Proton as well.
And one more thing I wanted to call out in the sample code is that the README has a lot of the details that I went over. It definitely explains pretty clearly. I hope it explains clearly all of the components of the code base. So like what's in each directory, what order do you need to deploy things? All of that information is there for you in the README. So do hop on over. And by the way, if there's anything that's not clear, please file an issue in the GitHub repo. I'll be more than happy to take a look at it and try to address it as quickly as possible. Also, if there's any mistakes in the code, likewise, please do file an issue and I'll try and get it fixed up. Okay, so I think we have time for like maybe one more question because we're a little bit over time. Craig, my former coworker, asks, how does Proton integrate with Code Catalyst, if it does at all?
Okay, so yeah, again, my computer's getting a little wonky here, but it seems like my audio is good. But
yes, audio is good.
Thank you. So, okay, so it's a good question. So, Code Catalyst really focuses on the developer experience, where developers can just kind of get pre-vetted blueprints, like kind of opinionated blueprints, and they can just click, kind of drag and drop their CI/CD workflow, and it's really focused on developer experience number one and having the opinion built in. Proton is opinionated in how we deploy infrastructure as code and how we deploy, but it's very extensible. So you can build on top of Proton. Proton enables you to use Pulumi, for example, or literally you could use Proton to deploy just a series of bash scripts if you wanted to. So that's kind of the main difference is Proton offers that developer platform, but the platform team is defining the opinion, where Code Catalyst is AWS has the opinion, and that you can leverage AWS's opinion there.
Cool. And we have one more question. Are there any particular features that make Proton different from open source solutions like Backstage?
Yeah, that's a good question, and it's a very common one. Backstage is really a really powerful developer portal. I would say that just the main difference between the two is just Proton is fully managed, very infrastructure as code focused, pipeline focused, and Backstage is really focused on the internal developer portal, where a developer can kind of get that documentation, get scaffolding. Like if they want to get in a sample project, a React project, for example, and get that repo, presented to them and kind of get the scaffolding. That's where Backstage really shines. But I would say they do have similarities, but also we have a Backstage plugin for Proton, as we do have some users that like to use Backstage, but they want to leverage Proton's versioning for the infrastructure as code in AWS.
Cool. All right. So I think that we should be wrapping things up. Unfortunately, I could keep going forever on this stuff. This is like one of my favorite topics to really cover. Some links for folks that are interested in learning some more. If you want to keep on top of our future workshops, please go to pulumi.com/resources. So I am easily findable on the Pulumi Slack. If you have not yet joined, I definitely encourage you to join. Hop on into either the workshops channel or even the general channel or the AWS channel. My name is Josh, and I'm pretty easy to find. I am the guy that looks like this and has the Pulumi icon next to my name that identifies me as a Pulumi employee. Adam has disappeared visually. I think he's still with us in audio. But on behalf of both of us, I really want to thank everyone for choosing to spend this time with us. We hope that this content was valuable, that you learned something useful that you can apply in the real world. Thank you so much for your attention. So long, everybody.